In Chapter 5, we looked at a binomial distribution or binomial formula to find probability. The probability of something happening was NCX, our combination, times P to the X times Q to the N minus X power. And as long as the numbers fit, this formula works pretty well until we get to have very, very, very large numbers. So for example, let's say I had 1,000 items to choose from and we wanted to find the probability of, say, 800. I'm just going to stop there. If I type that in my calculator, unfortunately I get what's called an overflow error. So since our calculator doesn't accept all those large numbers, we can go ahead and apply the normal distribution curve to that, but we do have to make what's called a correction for continuity. So basically what we're saying is we all know the normal distribution curve looks like this. Okay? Well, the binomial distribution looks just a little bit different. So it's off just a little bit. So it's a little bit different. So we have to make a correction of continuity by either adding or subtracting 0.5 to our value. Okay, so just to give you an illustration here, I have 5 criteria listed. But let's say I want to find the probability that X is less than 15 and our mean is, we'll say, 20. So down here at a quick sketch, oops, that's not a very good sketch, is it? So let's put our curve back up here again. Okay, so if I put 0 or 20 down the middle and 15 here, if this is a binomial, we know we either have to add or subtract 0.5. So I go ahead and shade. X is less than 15, means I'm going to shade to the left. The question is, do I want 15 to be in my shaded area? Is 15 less than 15? Well, it's not. So to make 15 not be in my shaded area, I subtract 0.5, and there is my correction for continuity. When I calculate my z-score, I use 14.5 rather than the 15. So I have to make a correction to make those curves match up. And again, it's either adding or subtracting 0.5. So let's go again. Let's say I want to find the probability that we're less than or equal to 15 this time with the same information. So I sketch a quick curve here. 0 and 20 goes in the middle. 15 on this side. This time it says less than or equal to 15, which means I want 15 in my shaded area. For that to happen, shading to the left, I have to go to this side of it. That way when I shade below, the original number of 15 is in my shaded area. And again, when I calculate my z-score, I have 15.5 minus 20 over my standard deviation to calculate. So my correction for continuity is either add or subtract 0.5. Let's keep other examples. Let's find the probability that X is greater than 15 this time. Say keeping the same mean and so forth. So I'm going to put my curve out here, 0 and 20 in the middle, 15 on this side. I want to shade to the right because of the greater than. 15 is not greater than 15, so my correction for continuity tells me to go to 15.5 because when I shade to the right, 15 is not part of my shaded area because 15 is not greater than or equal to 15. Another time here, let's say I want to find the probability that X is greater than or equal to 15. So when I put 0 here in the middle, or 0 and 20 in the middle, and I put 15 on this side, greater than or equal to means that 15 is part of my shaded area. So that means I should go down to 14.5 so that when I shade to the right, 15 is now part of my shaded area when I go to the right. And we have one more scenario that happens here, the probability that X is equal to 15. In this case, when I put 0 and 20, or my mean in the middle, and 15 on this side, my correction tells me I do both. I do 15.5 and I do 14.5 because that puts 15 in my shaded area, so I find the area between those two when I calculate two different z-scores, one for 15.5 and one for 14.5. And that's what's mentioned up here. I think the drawings probably make more sense to most of us, but you want to memorize these two criteria, by all means go ahead. But again, the shading should help us decide whether to add or subtract 0.5 as our correction for continuity. Quick little side note, or for this to happen, we have to have a distribution of a certain size. N times P and N times Q have to be greater than or equal to 5. Not going to be an issue. We kind of introduce this for larger numbers, but it does have to be a certain size in order for this correction for continuity to work and to be able to use a normal distribution curve with a binomial. Now also here, I guess I kind of skipped over this very quickly, but the mean and standard deviation calculations we had back in chapter 5 are reiterated here, because kind of the bottom line here, kind of a layman's term or shortcut method, very unscientific, is to say that we're going to use this binomial or this correction for continuity when we have to calculate our mean and our standard deviation ourselves. If you think back to the last 2 sections we've gone through with our application problems and our central limit theorem, we've been given the mean, we've been given the standard deviation. These problems will not have the mean or standard deviation given to us. We have to calculate those from the information that's presented. You'll notice that here right away in our first one. Magazine report that 6% of American drivers read the newspaper while driving. If 300 drivers are selected at random, find the probability that exactly 25 say they read a newspaper while driving. Any mention of a mean? No mention of a mean, no mention of standard deviation. So we'll calculate our mean as 300, that's our n, times our percentage, or probability, which is 0.06, so we'd expect to have a mean or average of 18. Our standard deviation is the square root of 300 times 0.06 times 0.94, n times p times q. If you recall, q is 1 times p, so 1 minus 0.06 is 0.94, and that gets us a standard deviation of 4.11. Okay, so that'd be the first item that I would note, is that we use our correction for continuity or our binomial approximation of the normal distribution when we have to calculate our own mean and our own standard deviation. So on our curve here, we have our mean of 18 in the middle, and we want to say exactly 25, so 25 would be on this side. Because it's exactly, that means our probability is equal to 25. So we're going to do a correction on both sides, 24.5 and 25.5. Let's try and clean that up a little bit. So 25 is there in the middle. I'm going to put my correction on one side to be 25.5. and my correction on the other side to be 24.5, and we're going to calculate a z-score for both of those. So for the first one, my z-score is 24.5 minus 18 over my standard deviation of 4.11, and that gets me 1.58. My second z-score is 25.5 minus 18 over 4.11. And that gets me a z-score of 1.82. When I look up those values from our table, table E, I get 0.9656 for 1.82, and I get 0.9429 for 1.58. I'm going to subtract those, and my probability is 0.0227. Okay, so there's exactly, we have to make both corrections for continuity. We added and subtracted 0.5. So we had 2 different z-scores to calculate, and that gave us our probability of 0.0227. Moving on, baseball players' batting average is 320. Find the probability that they will get at most 26 hits and 100 times at bat. So our mean is n times p. We have 100 times at bat. Our probability of getting a hit is 0.32. 32% of the time we get a hit. So our average, we expect to get 32 hits and 100 times at bat. Our standard deviation, square root of 100 times 0.32 times 0.68, and that gets us 4.66. So here we'll have our curve, 0 and 32 in the middle. At most 26, so 26 is going to be on this side. At most 26 means 26 or fewer, so for my correction, 26 needs to be in my shaded area, so I'm going to go to 26.5 and shade below. I'm not going to get any more than 26 hits, at most 26. So we calculate our z-score. We have 26.5, our correction for continuity, minus 32 divided by 4.66. And that gets me a z-score of negative 1.18. And then when I look that up, my table does again measure the area to the left. So the number I get is 0.1190 from table E. That is our actual solution here because That's the area to the left, and that's the area we were looking for. I think we have a couple more to go through here, so let's take a look at our next page. Of the members of a bowling league, 10% are widowed. If 200 bowling league members are selected at random, find the probability that 10 or more will be widowed. So notice no mention of a mean, no mention of a standard deviation. So our mean is our 200 members times our 10% chance of being widowed, so our mean is 20. Our standard deviation is the square root of 200 times 0.10 times the complement, which is 0.9, and that gets us a standard deviation of 4.24. Sketching our curve, we have 0 and 20 in the middle. 10 or more, 10 is going to be on this side. 10 or more means that 10 is part of my shaded area, so when I make my correction, I need to make sure that when I shade to the right, 10 is included, so it means my correction goes to 9.5 and we shade over to the right. That puts 10 in my shaded area because 10 is 10 or more. Our z-score then is that correction of 9.5 minus our mean of 20 over a standard deviation of 4.24 gives me a z-score of negative 2.47. I looked that number up in the table and it's 0.0068. Again, 0.0068 is our area to the left. We want the area to the right, so we'll subtract that from 1 and we get 0.9932. One more time here. Doctor's office claims that it keeps appointments on time 65% of the time. If 120 patients are seen in 1 week, find the probability that at least 65 patients will be seen on time. No mention of a mean, so we'll make our correction for continuity after we've calculated our mean and our standard deviation. So 120 times 0.65 is a mean of 78. Standard deviation, square root of 120 times 0.65 times 0.35, and that gets me a standard deviation of 5.22. So if we go to our curve here and put our information in, we have a mean of 0 or 78 in the middle. It says at least 65, so 65 is below 78. At least 65, 65 is at least 65, so that needs to be included in my shaded area, which means I would go to 64.5 and shade above. At least means that or more. So I'm going to shade on the right hand side. 65 needs to be included, hence the 64.5 is our correction for continuity. 64.5 minus 78 divided by 5.22. That gets me a z-score of negative 2.59. I look that number up, I get 0.0048. That again is the area to the left of the score I just calculated. I want the area to the right, so I subtract it from 1 and get 0.9952. So there's a look at our binomial approximation of the normal distribution, essentially that correction for continuity based on the fact that we calculated our own mean and our own standard deviation for these types of problems.